Hi you guys, today's lesson is on simplifying algebraic expressions, so please just make sure that you have your worksheets in front of you before you start this video, and I am going to go ahead and get started. For this lesson, I am going to start with a story. So, here we go. Once upon a time, there was these groups of families scattered across the country in a kingdom far, far away. The different family groups all decided to find the other members of their family so that each group could hold a giant family reunion. Each family could identify their other family members because they all had the same last name. There was even a family group with no last name. Now let's use our math properties to help these families join up with each other for their big family reunions. The first family is the x to the second power family. How many x to the second power families do you see? I see 2. 2x to the second and 5x to the second. Let's use the commutative property to move these two families together. Because we are dealing with addition here, remember we can add in any order and it doesn't change our expression. So we're going to go ahead and move the 2x squared families together. Okay, now let's go ahead and use the associative property to group these two families together and combine them for their family reunion. So if there's 2 x squared families and another 5x squared families, that would be 7x squared when we combine those. Okay, now let's do the same to group the xy, the x, the y squared families, and even the no last name family. So let's do the xy family. So 3xy, and right here, this is just 1xy. So let's go ahead and rewrite this using the commutative property. So these two families are together. And then let's go ahead and use the associative property and group these two families together and combine them for their family reunion. So 3xy and 1xy is going to be 4xy. Notice how when we combine them, their last name stays the same. Okay, let's do this for the x families. So we're going to rewrite this. And then after we have rewritten this, we can group the x families together and combine them for their family reunion. So 7x squared plus 4xy plus 5x. 3 plus 2 is 5. Okay, the next one I want to do is the y squared families. There's actually only one of those. Okay, and then what we have left is the families that don't have a last name. So 7x squared plus 4xy plus 5x plus 4y squared plus 10 is our simplified expression. Now, one thing I want you to realize is that as we were combining families that had the same last name, in order to combine them, they had to have exactly the same last name. For example, if we look at the x squared families and the x families, they both have an x, but the last name of this one is x squared, and the last name of this one is just an x, and those are not the same last name. And then I also want you to realize, as we were combining families that had the same last name, all we did was add the coefficients of those two terms. So we added the 2 and the 5, and that became 7, and then the last name stayed the same. We added the 3 and the 1, and that became 4, and notice the last name stayed the same. We added the 3 and the 2, and that became 5, and notice the last name stayed the same. And then, as we added the families that had no last name, we of course included no last name. Okay, now let's go ahead and use that analogy to help us simplify expressions. So number 1 says 8x plus 2x plus 2y plus 7y. So as we look at this expression and we simplify it, we are going to combine all of the families that have the same last name. So as we look at the 8x and the 2x, those two have the same last name. So we can combine those, and that would be a 10x. And then as we look at the 2y and the 7y, those both have the same last name, so that would be a 9y. And then we can't combine the 10x and the 9y because these two have different last names. Okay, on number 3, I want you to do example 3 with me. I want you to notice, and I'm going to write this bigger, 5x subtract 9x plus 2w subtract w, okay? On this one, we have addition and subtraction. And before we move any further than this, what I want you to do is change all of your subtractions to addition, okay? So we're going to take this subtraction right here, and we are going to keep, change, change, so that we're adding a negative 9x. We're going to take this subtraction after the 2w, and we're going to keep, change, change, and remember this is a 1w. Okay, now all we have to do is combine the families that have the same last name. So if we're combining a 5x and a negative 9x, that is going to be a negative 4x. If we're combining a 2w and a negative 1w, that is going to leave us with 1w. And we can't combine these two together because this one has a last name that is x, this one has a last name that is w. Okay, let's go ahead and look at number 5. Okay, I went ahead and wrote 5 a little bit bigger. And before we do anything with this one, let's go ahead and change all of our subtractions to addition. Okay, we have this negative 3 right here, and then we have an addition of 3x, and then an addition of an 11, and then we have a subtraction. So we are going to change this subtraction to adding a negative 5x, and then after the 5x, there's another subtraction. So we're going to change this to adding a negative 2k, and then there's another subtraction, so we're going to change this to adding a negative 1. This is a 1k. Now, let's go ahead and group our families that have the same last name. So, we have a positive 3x, and we have a negative 5x. So if we combine a negative 3x, if we combine a positive 3x and a negative 5x, that's going to give us a negative 2x. Okay, so we just combined these two. We can also combine the two families that have k as their last name. So if we combine a positive 2k, negative 2k with a negative 1k, that is going to give us a negative 3k. And then we have a negative 3 and a positive 11, and so when we combine those, we get a positive 8. Now, one thing we want to make it a practice of is when we are simplifying algebraic expressions, it's always best if we write the terms in alphabetical order of their last name, and then the term that has no last name, that's called a constant, and we always want to write that at the last of our expression. Okay, let's go ahead and look at number 7. Okay, so as we look at number 7, the very first thing that we want to do is we want to go through and change all the subtractions to addition. Okay, And then let's go ahead and just rearrange this so that the families that have the same last name are all written together. Okay, and then let's go ahead and simplify this expression. A 1x and a 5x, that's going to make a 6x. A 1 and a -2, that's going to make a -1. And a 4k and a -7k is going to be a -3k. So if we arrange this so that the terms are in alphabetical order of the last name with the constant at the end, this would be our simplified expression. Okay, now let's look at a few more examples. We're going to move to looking at 10, 12, 14, and 16 together. What I want you to notice about these is that the coefficients of these terms, some of them are fractions. Okay, so as we look at the coefficient of this term, that's a 2/3, and the coefficient of this term is a 1. Okay, now we follow the same rules that we did when we were combining the like terms for the ones that didn't have fractions. Okay, so these two have the same last name. They both have an x, and in order to combine them, we're just going to add the two coefficients together. So we're going to add the 2/3 with the 1, and that would just be 1 and 2/3 x. Okay. Now we're also going to add these two constants together. A 3/4 and a -1/4 is going to be a 2/4, which can simplify to 1/2. So our final simplified answer for this expression would be 1 and 2/3 x plus 1/2. Let's look at number 12. The two families that have the same last name are the 5/3 x, and this is actually going to be adding a negative, so this is going to be a -2/3 x. And then we have a 4/5, positive 4/5, and we also have, we're going to change this to adding a negative, so we have a -3/5. So if I were to rewrite this using the commutative property, I could write this as 5/3 x plus a -2/3 x plus a -2/3 plus a -3/5. Okay, and now we want to combine the coefficients of the two terms that have the same last name. So if we combine a 5/3 with a -2/3, that's going to give us 3/3 x. And you guys know anytime we have the same thing divided by itself, that would just be a 1. So this becomes a 1x when we combine these two together. Okay, now in order to combine these two together, the constant terms, we're going to have to find a common denominator, which is 15. So we have to multiply this by 5 and this by 5, which gives us -10, and this by 3 and this by 3, which gives us -9. Now we can combine a -10/15 and a -9/15, and that's going to be a -19/15. Okay. Let's go ahead and look at number 14. Okay, so in 14 we have 3m plus 1/4 m plus 2y plus 3/4 y. Okay, now remember, if a number is right next to a variable, there is implied multiplication between those two. So this is really 3 times m plus 1/4 times m plus 2 times y plus 3/4 times by y. Okay, and let's go ahead and simplify this expression by combining the like terms. Like terms are the terms that have the same last name. Another way of saying that is to call them like terms. So if we combine a 3m and a 1/4 m, that's just going to be a 3 and 1/4 m. If we combine a 2y and a 3/4 y, that's just going to be a 2 and 3/4 y. Let's look at number 16. Now, as we look at number 16, I'm going to go ahead and rewrite this. But before I do that, I want us to realize that we're going to change this subtraction right here to adding a negative, this one to adding a negative, and this one to adding a negative. Okay, and now I'm just going to group the terms that are like terms together as I rewrite this. So -5 plus -7. So I just took those two. And then we have a positive 1/2 times by x. And we have a positive 3/4 times by x. So we can write those two together. And then we have a negative 1/5 y. And we have a negative 2/10 y. Okay, so now let's go ahead and just combine our like terms. We know that a -5 and a -7 added together would be a -12. In order to combine the 1/2 x and the 3/4 x, we're going to find a common denominator, which is 4. We have to times this by 2 and this by 2. So 2/4 x plus 3/4 x becomes 5/4 x. And then to combine these two together, one thing I want you to realize is that we can simplify 2/10. 2/10 simplified is actually just 1/5. Okay, so if we combine a -1/5 with another -1/5, the denominator is going to stay the same. A -1 and a -1 would be a -2/5 times by y. Now, the only thing we need to do here, and we don't have to do this, it doesn't change the value of our expression, but it's just a good practice in math to always write your terms in alphabet order of the variable, with the constant term being the last one that you write down. Okay, so now at this point, I want you to take your worksheet. I went through the odds of the first page, and I want you guys to do the evens. Okay, so you're going to do the evens of the first page, and then I went through the evens on the second page. Okay, so you're going to do the odds on the second page. Once you have completed both the evens and the odds on both sides of this worksheet, I want you to bring it back to me so that I can check these off with you and give you the next part of this assignment.